Quicker than the texture of spacetime can stay aware of it, it'll simply tear, and I'm scared by this right now. Our night sky is changing quickly, and in simply an issue of many years, if not mere years, it could turn out to be completely unrecognizable. Cosmologists around the world are sounding the alert. Specialists like Neil deGrasse Tyson have recently confirmed the inevitable explosion of Polaris, and the story behind it is quite startling. Polaris, known as the North Star, has long been a constant presence in our night sky, serving as a critical reference point for stargazers, pilots, and navigators. However, this could soon change, altering our night sky and impacting astronomical measurements. Let's dive into the significance of this threat and its implications for all of us. Join us as we uncover the tale of Polaris as it approaches its end. For centuries, Polaris has guided sailors and stargazers alike, holding a revered position as a guiding light. Its steadfast presence in the night sky has been essential for navigation, yet this stability may soon be disrupted. In September 2023, a research paper presented by the esteemed Royal Astronomical Society cast doubt on the fate of this celestial illuminator. Polaris is on the verge of exploding, possibly disappearing from the night sky forever. Before we explore the consequences of this discovery, let's understand more about Polaris. Also known as the North Star or Pole Star, Polaris is unique due to its proximity to the celestial North Pole, positioned nearly directly above Earth's North Pole. It appears almost stationary in the northern sky, located in the constellation Ursa Minor or the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, much larger and brighter than our Sun. It is not a single star but part of a complex triple star system, with Polaris AA and Polaris AB forming a binary pair while Polaris B orbits around them. The interactions between these stars create gravitational forces shaping their orbits and affecting their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or pulsation patterns. However, the exact mechanisms behind these interactions remain unclear. Polaris is located approximately 323 light-years from Earth, meaning the light we see from it today began its journey centuries ago. Consequently, if Polaris were to explode now, we wouldn't observe it until over 3 centuries later. It's even possible that Polaris has already exploded, and we are yet to witness the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic significance. Its steadiness and fixed position made it an invaluable guide for ancient sailors, helping them navigate across oceans and lands. Symbolically, Polaris represented stability and guidance, remaining steadfast amid the ever-changing night sky. For astronomers, Polaris served as a crucial reference point, assisting in the study of celestial motions and variable stars. As a Cepheid variable star, its periodic variations in brightness have provided essential insights into stellar properties and the nature of variable stars. This characteristic also played a vital role in determining cosmic distances and calibrating instruments. These pulsations follow a predictable pattern, which has been the standard for the star, making it easy to anticipate its behavior. However, recently, Polaris has deviated from this regular behavior. This anomaly in its pulsation cycle has puzzled astronomers, prompting a closer examination of this celestial phenomenon. Rather than its typical predictable pattern, Polaris has begun exhibiting unpredictable cycles of dimming and brightening. Researchers are now raising concerns that the star may be nearing the end of its life. This aligns with behaviors commonly observed in stars nearing their end. The gradual increase in Polaris's pulsation period, once stable, can be attributed to interactions within its star system. We have observed an annual increase in the pulsation length by 4 to 5 seconds, which may seem minor but hold significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be causing these changes in its atmospheric conditions, directly affecting its pulsation patterns. However, others are more alarmed, believing that the star is on the verge of exploding. The similarities between Polaris's behavior and that of Betelgeuse, another notable star in the Orion constellation, are striking. Both stars have shown puzzling anomalies in their luminosity, raising concerns about potential explosions. Cepheid stars in their late stages often exhibit such anomalies before reaching the climax of their life cycles. While NASA has expressed heightened concern about Betelgeuse, similar attention hasn't yet been officially directed toward Polaris. As a Cepheid star approaches the end of its life cycle, it progresses through various stages, including the main sequence stage, red giant stage, and ultimately the supernova explosion. Based on Polaris's irregular pulsations, scientists predict it has entered the stages of helium depletion, typical of Cepheid stars approaching their end. These anomalies in Polaris's behavior align with patterns indicative of Cepheid stars in their twilight stages. However, definitive signs of its impending supernova remain uncertain. Astronomers are diligently analyzing these anomalies to understand Polaris's fate. If Polaris were to go supernova, it would likely be a spectacular event in our sky, possibly outshining the Moon and becoming one of the brightest objects visible for several days, weeks, or even months. Its appearance could change significantly for a time, altering our view of familiar constellations like the Big Dipper, or Ursa Major, of which Polaris is a part. Rest assured, Earth would likely be entirely safe even if Polaris were to explode, given its mass and distance from us. While a Polaris explosion may not be as visually impressive as Betelgeuse, it could still be visible to the naked eye for an extended period and outshine nearby stars. Astronomers and observatories would undoubtedly take notice, sparking interest within the scientific community and among stargazers worldwide. However, the specific visibility and impact on Earth's atmosphere or surroundings would be less significant compared to a closer supernova event. But what about Polaris itself? What will be its fate after a potential supernova event? Let's clarify one thing: while giant stars typically end their lives with a supernova, this is unlikely to be the case with Polaris. When a massive star goes supernova, a tremendous explosion occurs within it, marking the final catastrophic stage in its life. This process involves a complete core collapse, triggering an intense shock wave that causes the star to explode violently. However, Polaris isn't massive enough to undergo such an explosion, such a blast. Rather, when Polaris depletes its atomic fuel, it will shed its external layers and transform into a white dwarf. This change will not lead to a super-cosmic explosion, rather, it will bring about a tranquil end as it evolves into a small, incredibly dense celestial remnant. A white dwarf is the remnant of a low or medium-mass star that has exhausted its nuclear fuel. It is unimaginably dense, as massive as the Sun yet compacted to the size of Earth. When this occurs, we will no longer be able to observe its remnants from our planet, much as we view the star today. Examining the anticipated effects of Polaris explosion, alongside historical supernova events, provides important insights into the evolution of stars and their ultimate destinies. Comparing our expectations with actual supernovae, like SN 1987A, and more recent events such as SN 2011 Fe or SN 2014 J, provides valuable data for understanding the potential consequences of Polaris burst. SN 1054, for instance, resulted in the formation of the Crab Nebula, a cloud that continues to expand and emit radiation across various wavelengths, offering astronomers a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, provided insights into nucleosynthesis processes and the dynamics of supernova remnants. Exploring phenomena such as the formation of nebulae, the release of cosmic rays, and variations in brightness can offer insights into Polaris' unique characteristics. The development of clouds like the Crab Nebula results from the ejection of material during a supernova explosion, which interacts with surrounding interstellar gas and dust, enriching it with heavy elements and contributing to the cycle of stellar birth and death. Furthermore, the release of cosmic rays, high-energy particles accelerated by the supernova shockwave, has implications for astrophysical processes and cosmic radiation environments. To create a comprehensive analysis, scientists evaluate differences in mass composition and velocity of ejected materials between Polaris' anticipated burst and other observed events. This involves examining light curves, spectra, and remnants from these events and projecting similar characteristics for Polaris' expected burst. Assessing whether Polaris' explosion could lead to the formation of nebulae or distinct elemental distributions enhances our understanding of its potential outcomes. Another important area of study involves examining the pulsational variability of stars nearing their end stages, like Polaris, against observed supernova precursors. This comparative analysis can help gauge similarities or deviations and provide insights into the explosion mechanism. Pulsational variability in stars approaching the end of their lives may indicate internal instabilities or impending catastrophic events, offering clues to the evolutionary processes leading to supernova explosions. Despite meticulous observations and extensive research, astronomers find themselves puzzled by the anomalies observed in Polaris behavior. Unraveling the unique conditions driving these irregularities holds the key to advancing our understanding of stellar evolution. Understanding the mechanisms responsible for Polaris' irregular pulsations requires interdisciplinary collaboration and the development of advanced theoretical models and observational techniques. The potential loss of Polaris as a prominent reference point in the night sky presents significant concerns for astronomical endeavors. Ground-based telescopes and celestial measurements would require recalibration, affecting the accuracy of astronomical assessments. The absence of Polaris could also impact navigation systems and cultural practices reliant on celestial landmarks, underscoring the significance of this cosmic event. The puzzling behavior exhibited by Polaris highlights the need for deeper investigations and dedicated research efforts. Astronomers must grapple with the complexities surrounding its irregular pulsations and provide concrete answers. Recognizing the importance of advancing our understanding of stellar complexities, ultimately, the answer to Polaris' fate remains uncertain, and only time will reveal its true nature. Regardless, the pursuit of knowledge and understanding in the face of cosmic uncertainty is a testament to humanity's enduring curiosity in unraveling the mysteries of the universe. As we ponder Polaris' fate, it's essential to recognize its role not just as a celestial marker but as a window into broader astronomical phenomena. The North Star has been central to humanity's understanding of the night sky. Ancient cultures used its position to develop calendars and seasonal agricultural practices, linking celestial events to earthly activities. As civilizations progressed, Polaris' stable location offered navigational aids that facilitated exploration and trade, marking it as a cornerstone of maritime history. In modern astronomy, Polaris serves as a crucial alignment point for telescopes and observational instruments. Its consistent brightness has allowed astronomers to refine their measurements of distance across the universe. The star's predictable light output contributes to the cosmic distance ladder, a vital tool for measuring distances to distant galaxies and understanding the expanding universe. Interestingly, the study of Polaris also opens avenues for exploring stellar evolution. By examining its life cycle, scientists gain insights into the broader life cycle of similar stars. The properties of Cepheid variables, including their pulsation periods and brightness variations, allow researchers to draw comparisons with other stars, enhancing our understanding of stellar characteristics across different stages of life. As we explore the final stages of a star like Polaris, we must also consider the implications of its eventual transition into a white dwarf. This process is a fate shared by many stars in the universe, leading to the formation of stellar remnants that will linger for billions of years. The study of white dwarfs has profound implications for our understanding of stellar and cosmic evolution. Additionally, the interaction between dying stars and their surroundings is a fascinating area of research. When stars shed their outer layers, they contribute to the interstellar medium, enriching it with heavier elements formed through nucleosynthesis during their lifetimes. This recycling process is crucial for the formation of new stars, planets, and ultimately life itself. By examining the remnants of stars like Polaris, scientists can trace the pathways of matter through the universe. The potential explosion of a star like Polaris raises questions about its impact on the surrounding stellar environment. While its distance from Earth provides a layer of safety, the energetic phenomena associated with supernova events, such as shockwaves and the release of high-energy particles, can influence nearby star formation processes. This can lead to periods of intense star formation or trigger the collapse of gas clouds, resulting in the birth of new stellar systems. Beyond its scientific implications, the story of Polaris represents philosophical reflections on humanity's place in the universe. As our understanding of stellar life cycles grows, we are reminded of the transient nature of celestial bodies. Just as Polaris has guided humanity for centuries, its eventual transformation will mark a shift in our night sky, serving as a poignant reminder of the inevitable changes that permeate the universe. Astronomy has often inspired questions about the future of our planet and species. As Polaris approaches its inevitable fate, it urges us to consider our own existence and the legacy we leave behind. The pursuit of knowledge about stars like Polaris fosters a sense of wonder and curiosity that transcends generations. Ultimately, ongoing observations and advancements in technology will allow astronomers to monitor Polaris more closely than ever before. Upcoming telescopes and space missions are designed to capture unprecedented detail in stellar behavior. These observations will not only illuminate the life and death of Polaris but also enhance our understanding of the broader universe. In conclusion, the story of Polaris extends far beyond its immediate visibility in our night sky. It embodies centuries of human exploration, serves as a critical benchmark for astronomical measurements, and invites us to ponder the deeper questions of existence. As we witness the fate of this revered star unfold, we partake in a larger narrative about the cosmos, a story that continuously shapes our understanding of life, time, and the universe itself.